Welcome back, honors and Algebra 2 and Algebra 2 students. We are on the last section of this unit, and it's going to talk about recursive and explicit rules, which is very similar to what we've already kind of been talking about, but with a little bit of a change. So first of all, just some definition again. An explicit rule gives a sub n as a function of terms, position number n in the sequence. So in other words, it's kind of giving you an explicit rule. What I want you to think of it is an equation. It's not like the formal definition, but that's kind of what we're kind of referring to. So an explicit rule is like your a sub n equation, whereas a recursive rule kind of tells you a starting point. So it gives you, we'll say, beginning terms, and then tells you what the pattern's going to be. Okay, so let me show you kind of the difference between the two. So, for example, an equation might be something like a sub n equals 5 plus 2n, right? So what this explicit rule tells me is that it doesn't, so that 5 is not my first term. So if you remember in our general equation, right? This is for arithmetic, right? This is kind of like after you already distributed everything in combined like terms. So think of this as kind of like your linear equation, right? This would be your zero term. So an explicit rule kind of starts with like your, I don't know, like your zero term, if you will. But it gives you a rule for what you're going to be doing to get to the next term, right? So we're going to have our zero term be 5, which means we're going to be adding 2 each time. So if I wanted to, I could figure out that the first term in my sequence would be, so again, I would have 7 would be the first term in my sequence, because if this is my zero term and I'm adding 2 each time, you know, this is that made up kind of zero term, then we know that our first term of our sequence would be 7, and then the second term of our sequence would be 9, and so forth. Whereas with a recursive rule, let's say something like, I'll give you our first term. So I'll tell you, let's say 5 is our first term. And then I'm going to tell you our a sub n term is going to be something like this, where I'll say a sub n minus 1 times 2. So what this implies here, n minus 1, implies that we're talking about a previous term. So if n refers to the term we're talking about, right, n minus 1 refers to the term that came right before it. So then the rest of this is kind of what you're doing to get to your next term. So in this case, we're taking the previous term and we're multiplying it by 2. So in a recursive rule, you have to be given kind of like a starting value, right? So you have to kind of be told where to start. So if I was to write out the sequence, I would know that my first term is 5. My second term is, so I follow the pattern. The pattern says take your previous term and multiply by 2. So my third term would be take your previous term and multiply by 2. So 10 times 2 is 20. So what you're doing is this is a geometric sequence, right? You're taking your previous term and you're multiplying by 2. So rather than giving you kind of like your a sub n equation, it's telling you kind of in a little bit more, in a different manner about how you can kind of generate your sequence. So there's a couple formulas that I'm going to add to my formula sheet that you may add if you would like. And so this one is for an arithmetic recursive equation. And this one is for a geometric recursive equation. And pretty much it's common sense. Okay, so what I mean by that is, so I'm going to add them over here to my recursive. I'm going to call it recursive. And so what I mean by that is for arithmetic, it means, again, this means your previous term. So n minus 1 means your previous term. You are just going to be adding whatever your common difference is. So if you're subtracting 2 every time, then this would be a sub n minus 2 minus 2. If this is, a sub n minus 1 minus 2. If you were adding 20 each time, this would be a sub n minus 1 plus 20. In a geometric sequence, what you'd be doing is taking your previous term and multiplying by a common ratio. So again, like in our example that I just did, I multiplied by 2. So my common ratio is 2. I multiplied by a sub n. That was my recursive rule. So again, all you're really kind of knowing here is we're learning kind of a new terminology. And this a sub n minus 1 means previous term. Let's go a couple examples. So we'll start with the first one here. All right, so if I tell you a sub 0 is 81, and then I give you a sub n is 1/3 a sub n minus 1, write the first 6 terms. So technically this does not count as one of your terms, okay? So the first 6 terms literally means a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So that's what we're referring to when we say the first 6 terms. So we can count this one if we want, but technically if I'm looking for the first 6 terms of my sequence, normally we start at 1 and go to 6. All right, so if we have 81 as kind of our starting value, what this rule is telling me to do is to take my previous term and multiply by 1/3. So if I take 81 and multiply by 1/3, I get 27. So my first term of my sequence is 27. And again, apply my recursive rule. So my recursive rule says take your previous term and multiply by 1/3. So 27 times 1/3 is 9. And again, keep multiplying by 1/3, keep multiplying by 1/3, keep multiplying by 1/3. So what we're doing here is, again, we're just kind of using our recursive rule to generate the terms in our sequence. Another example would be something like where I have you write a recursive rule. So I'll just kind of write down, this is what the directions would say. So write a recursive rule for, and then I'll give you a pattern. -11, -6, -1, 4, 9. So in this case, I'm not telling you whether it's geometric or whether it's arithmetic. And so it has to be, it generally is one of the two. Obviously, it could be neither. But if you look at this, kind of you want to figure out what you're doing to get from one term to the next. That's kind of your first, I guess, step. So if you notice from -11 to -6, I'm adding 5. From -6 to -1, I'm adding 5, I'm adding 5, I'm adding 5. So what this tells me is that this is going to be, an arithmetic sequence. So I'm going to use, so if I'm going to write a recursive rule, I'm going to write a sub n, but I also have to kind of have a starting value. So I'm going to start with my first value, which is -11, and then I'm going to say a sub n minus 1, because that means the previous term. And what am I doing to get to the next term? I'm adding 5. So this is what you would need to give me if you're writing a recursive rule. You would need to tell me where to start and then how to get to the next terms. So again, the difference between a recursive rule and an explicit rule, an explicit rule is kind of like your a sub n term, like your equation, whereas a recursive rule doesn't really give you kind of like your basics in your equation. It tells you what to do to get to your next value, and it tells you kind of where to start, but it doesn't write the actual equation for you. All right, let's do some example problems. So if you would please go ahead and find page 239. We're not going to do all of these, but we're going to do quite a few of these. All right, so we're going to start with number 2. Just because some of this is looking a little different than what you would normally see. So this says f of 0 equals 1. So again, what they're asking for is the first 6 terms. So this time we're going to count f of 0 as one of our terms, since they gave it to us anyway. So my first 6 terms, we'll just go up to f of 5, because that would give me 1, 2, 3, 4, 5, 6. Okay? All right, so this tells me, read what this recursive rule is telling me to do. It says 2f of n minus 1. So in words, what this means is multiply the previous term by 2. That's ultimately what you're doing. So you're taking this previous term and you're multiplying it by 2. And so then you could generate your pattern. And that's all you're really doing. So again, it's just kind of a new way of kind of looking at how we can write this pattern. Let's do a couple more. Let's try number, let's try number 4. All right, so this one is asking you to write a recursive rule. Again, we kind of did one of these on the last page. So let's look at one that's a little bit different. So you want to determine if it's geometric, if it's arithmetic, or if it's neither. So again, one of the ways you can determine is you're looking at, like, if you want to find a common difference from 50 to 20, you're subtracting 30. Obviously from 20 to 8, I'm not subtracting 30, so I know it's not arithmetic. To get geometric, what you want to do is take your second term divided by your first term. So I'm just going to do 20 divided by 50, and I get 2/5, which is 0.4. Okay, and then I'm going to do 8 divided by 20, and I get 0.4, or in other words, 2/5. So what I noticed is that I'm multiplying by 2/5 every single time. So I know this is going to be a recursive rule that's geometric. So again, you start with your first term. So tell me what the first term is, and then tell me what to do to get to the next term. Well, you take your previous term and you multiply by 2/5. So this is the recursive rule I'm looking for. All right, let's do a couple more challenging ones that are not quite as obvious. So if you look at 3, 4, 1, -3, -4. So first of all, if I add 1, I get to 4, but obviously if I add 1, I'm not going to get to 1 again. So it's not geometric. It's not going to be arithmetic, or it's not arithmetic. It's not geometric either, because 4 divided by 3 is 4/3, but 1 divided by 4 is 1/4. So I know there's no pattern there. So this is what we call a neither, right? So we have to kind of think about what we're doing to get from one value to the next. So if I do 3, 4, I get 1, 3, 4, 1, -3, -4. This is a fairly hard pattern, and I don't know if you would have probably known this if I didn't already tell you this. So this is just a kind of a good example to kind of stretch our minds here a little bit. In this example, I have to give you the first two terms. And so I don't know if you noticed it, but basically, if you got 3, 4, 1, -3, -4, 1 is the difference between 4 minus 3. And then -3 is the difference between 1 and 4. And -4 is the difference between -3 and 1. Again, very challenging pattern to kind of come up with on your own. How would I write that? Well, the reason I'm giving you the first two terms is because I can't do this pattern without knowing the first two terms. And so essentially what you're going to do is you're going to take the previous term and you're going to subtract the next previous term. So look at how I wrote that. So in order for me to kind of generate a rule, like how do I get to the next term? Like if I was to come up with this next number here, right? I would have to take my previous term, which is -4, and I would have to subtract the next previous term, which in this case is -3. And so I would get -1. So this means your previous term, and this means your second previous term. So I don't know how else to word that, but basically means if this is your previous term, this is the one that came before it. And so the pattern was to take the term that came right before the one you're looking for and subtract the one that came before it. So this is the rule that you would use to generate that. Let's look at another one that's a little, I guess, challenging. So if you look at 1, 1, 1/3, 1/4, 1/15. So on this one, this is your first term, right? This is your second term. This is your third term. This is your fourth term. This is your fifth term. So if you noticed, you're kind of, like all of these are kind of relating to the term that you're dealing with. So again, notice that we start with 1 and 1. So I am going to list my first two terms here. My pattern here is I am going to take, so to get to 1/3, here's 1/4, 1/5. I'm going to take my previous term, so I'm going to take a sub n minus 2 and divide by n. So what that means is I'm going to take the term that came 2 before it. So in this case, like if I was to figure out 1/3, I would take the term that came like 2 spots before, so 1, and divide by n. So this means 2 terms before And this means your current term. So n is the current term you're on. So if I take the number, in this case, if I take the one that came 2 spots before, which is 1, divide by my current term, which is 3, I get 1/3. If I take, to get 1/4, I would take the one that came 2 spots before, which is 1, divide by 4 is 1/4. To get 1/15, I would take 1/3, which is the one that came 2 before, and divide by 5, which would give me 1/15. So to get to my next term, I would take, so to get to this term here, I would take 1/4 and divide by 6, because it would represent my 6th term. So 1/4 divided by 6 is 1/24. And again, those are some challenging ones. I'm not necessarily, looking for you to kind of generate those on your own, but I was looking to see if you could kind of come up with those just to kind of see some different patterns in dealing with recursive. All right, let's look at page 240. On this one, we're going to do a couple different problems here. We're going to start with numbers 9 and 10, and then we'll go, we're writing a recursive rule for this one. Okay, so on number 9, what we're doing, okay, so let's look at number 9. We're writing a recursive rule. So again, the recursive rule is the one where you have to kind of start with your, recursive rule is kind of where you're going to tell me where the starting value is, and then you're going to tell me kind of like your first term, and then you're going to tell me my a sub n pattern, like what am I doing to get to the next term. So if this is my equation, remember, this is not your first term. This -1 is actually your 0 term, right? Because it's kind of like your y-intercept. This right here, this 8 is your common difference. That's like what you're doing to get to the next term. So if I add 8 every time, my first term would have to be 7. Because if I'm starting at -1, I add 8, I get 7. So my pattern is to take my previous term and add 8. Let's try another one. So in this one, it's a geometric. Notice how it's an exponential equation. This one's fairly easy. You would need to know your first term. Well, my first term would be this -3 out in front. So remember, your first term in your pattern or in your equation would be -3. Plug in 1 for n. My recursive rule would be to take, what this means is to take your previous term and multiply by your common ratio, which in this case is 3/4. So this is the recursive rule for this explicit rule. Let's go the other way around. So now I'm asking you to write the explicit rule given a recursive rule. So let's try number 11. So I'm telling you that a sub 1 is -1, and I'm telling you that the pattern is to take your previous term and add 7. So remember, you're writing an explicit rule. So an explicit rule is just your a sub n rule, without kind of like your basic a sub n rule that we've done before. So what I'm giving you by giving you this information here is I'm telling you your first term and I'm telling you your common difference. The common difference is what so I'm adding 7 each time. That would be your common difference. So I recognize that this is arithmetic. And so I'm just going to plug in the information into my equation. So I'm going to plug in my first term. I'm going to plug in my common difference. And I'm going to simplify. So my explicit rule is 7n minus 8. So in other words, I'm starting at, my first term is -1, and I'm adding 7 each time. And that kind of shows up in your equation. Let's do another one. So number 12. So again, this is your recursive rule, because it's telling you where to start. So your a sub 1 term is 24. It's telling you what you're doing to get to your next term. So it's saying take your previous term and multiply by 0.2. So what I'm giving you here is your common ratio is 0.2. Because again, this is recursive, this is a geometric because you're multiplying by a constant amount. So if we write our explicit rule, all you're doing is kind of plugging in your information. So I'm plugging in my first term, plug in my common ratio to the n minus 1. Let's do one more. Number 14. So notice I'm giving you your first term is -2. What am I telling you here? I'm telling you to take your previous term and multiply by -5. So I'm giving you a common ratio. So now you know that this is geometric. So you would write your equation by following the geometric rule, which is a sub 1 times r to the n minus 1. So this would be -2 times -5 to the n minus 1. All right, that's it for this video. If you have any questions, I would maybe practice some of this stuff on big ideas. If you have any questions, bring them to class. I'd be happy to kind of go over them. All right, bye for now.